Hello everyone, welcome to this online course on manufacturing processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So we are we're discussing this metal forming. Already we have discussed forging and we have started extrusion. In extrusion, last lecture was totally based on extrusion. We saw what extrusion is all about, and we also saw two of the processes of extrusion. What is the meaning of direct extrusion and what is the meaning of indirect extrusion? Also, we saw what is the difference between these two and indirect extrusion, especially if friction is there. We know there will be huge friction. So, how to reduce those friction? And in indirect extrusion, we saw how indirect extrusion is majorly applied, and if we are applying this in indirect extrusion, so what will be the effect on the material microstructure, and hence what will be the effect on the mechanical property of the material which has been extruded by this one. Now we are continuing this one, and today most probably will complete the extrusion process. So we are continuing yesterday's lecture, last lecture, and in today's lecture what we will cover other extrusion processes are there. These are the special extrusion processes, means it is not direct indirect extrusion. These are the special extrusion processes. So first we'll cover this one, and then we'll take what are the defects which generally occur during the extrusion of a product, and then of course we'll see what is wire drawing, rod, and rod drawing. Okay, so one by one we are going to discuss in today's lecture all these four sections. We'll start with the impact extrusion, then we'll come to the hydrostatic extrusion, then extrusion defects in detail, and then what is wire and rod drawing. So we are starting with the impact extrusion. Impact extrusion, as the name suggests, whatever the forces we are applying, okay now, whatever the forces we are applying to extrude the product, means deform the product, it is not going to be gradual, just like we used to apply force to the ram. Okay, so that force was used to be gradual. Here force is not going to be gradual, it will be applied in sudden form, means suddenly will apply the load. So what this impact extrusion, what it is performed at high speed and shorter strokes. Okay now, so speed will be very high. Suppose this is stylus, through that we are applying the force, and this is the workpiece where we have to deform this one. So suddenly we'll apply the force, so what will happen, duration will be shorter, and this force through which this velocity is changing, it's going to be very high. So that's what is very important that need to understand in this one. The higher speed and shorter strokes will be there in this one. Okay, billet is extruded through the die by impact pressure, and not just by the pressure. Okay, pressure will be impact because force is impact, so obviously area is constant, so it is going to be impact pressure over there. But impacting can be carried out as forward extrusion, backward extrusion, or combination of this one. Now this is very important to understand. Typically it is not going to be a direct extrusion or indirect extrusion. It may be direct extrusion. The way of applying the load, it is not going to be gradual. What is happening here, suddenly we are applying the load, but that load application means that movement of whatever the means we are using to apply the load, the movement of that one and the extruded product both may be in same direction, just like direct extrusion, both may be in opposite direction, just like indirect extrusion, or it may be combination of those. So if you'll see the diagram here, just see first one. What is happening here is our workpiece, and through this punch we are applying the force. So what is happening, once we'll apply this one, so this movement of the force through this punch we are applying, what is happening, it is moving in downward direction, and once we will apply the force, just this, see this specimen, it is going up. Okay, so what is happening, it is in opposite direction. Okay, here also you will see it is opposite direction, and here both things are there. Sorry, here it in same direction where you are applying the force, it is moving in same direction. So we know this is a direct extrusion. So this is a direct extrusion, but here it is opposite. You are applying the force, this is your ram movement, you are applying the force and your workpiece is here. So finally how it is moving, it is moving in opposite direction. So here the movement of the extruded product and here the movement of the ram, both are in opposite direction, just like indirect extrusion. So here this impact extrusion process is in direct, just like direct extrusion, means both are moving in same direction. Here we can see both are moving in opposite direction, and here in the third diagram we can see both of this is possible in a single pass. Means this impact extrusion simultaneously may be direct extrusion, it may be indirect extrusion, combination of these two. Okay, that has been written here. Impact extrusion is carried out as a cold forming, means it is generally deformed, the material is being deformed at room temperature, so approximately at 25 degrees centigrade. Very thin walls are possible by backward impact extrusion method. Example, making of toothpaste tubes by tree cases. It's possible to produce by this process very thin wall of the extruded product, just like a toothpaste. Okay. What is the advantage of this one? Large reduction is possible by this process. This is the major advantage of this process. Large reduction is possible, and obviously production rate is very high in this one. So these are the two major advantages of this process. What are these two major advantages? As production rate is very high, this is the one of the advantage. And the second advantage of this process is a large reduction in single pass is possible by this process. Next process is which is known as hydrostatic extrusion. Here there will be no friction at all. So what this process is and what actually this process means? The meaning of this process, you just see this diagram. This is the container and this is our workpiece. So what is happening in between? There is a space. This is the dummy block, and between this dummy block and this billet or the workpiece, there is a space where the liquid is completely filled. Okay. So what is happening here? Here also we have to apply the force. The thing is we are not applying force directly. Means it is not like this dummy block or this ram is indirectly in contact with this one, and then we are applying the force, and then because of that force it is coming out from the die opening and it is taking the shape of the die opening, or it is being deformed over there. Instead of that, what is happening here, in between this one, means between the billet and this dummy, there is a liquid field. So when we'll apply the force through this ram, what it will do, it will apply pressure. So this liquid inside will be in high pressure, and as this is in contact with the billet, so that liquid pressure through that liquid will be transferred to the billet. So it will exert force on the billet, and it will force billet to pass through this die opening. So finally it is going to pass through this one, flow through this die opening, and finally it is going to take the shape, whatever shape we want. But what is happening here? Instead of directly bringing the ram in contact with the billet, what we are doing, in between we are placing a liquid, and through that liquid we are applying the force. So what is happening here? What it will be, there is no friction at all, because there is no direct contact between this billet and this container. Also there is no direct contact between. Always there will be, whatever the contact area are there, in between always there will be liquid, and as there is a liquid, that liquid will work as a lubricant. So what will happen? There will be no friction at all. So whatever the losses that can occur during the process of the processing because of the friction is completely eradicated in this process. So what this process says, in hydrostatic extrusion, the billet is surrounded with a fluid. You can see inside the container, and fluid is pressurized by the forward motion of the ram. This forward motion, because of this ram, we are applying the force. So obviously it will be in pressure, this liquid. There is no friction inside the container because of the fluid, and friction is minimized at the die opening. Even this area also friction will be completely minimized. Means it will be very less in this area. Okay. If it is used at high temperature, a special fluid and producers must be followed. Yeah, obviously whenever we are using this fluid, we'll have to keep in mind, if we are working at a high temperature, so we'll have to keep in our mind that at that particular temperature, whatever the fluid we are using during the processing or extrusion, that should sustain their property at such a high temperature. So whenever we are doing hot extrusion, so whatever the liquid or the fluid we are choosing to use in this process, that need to be chosen carefully, so that at that high temperature its property completely should be sustained over there. Yeah, so that has been written. Hydrostatic pressure on the work and no friction situation increases the material's ductility. This is the most important property of this process. There is no friction, and also the friction is not there, so obviously the material ductility will be high. Hence, this process can be used on metals that would be too brittle for conventional extrusion process. And this is the reason. Actually, what happens whenever the material is brittle, it is very difficult to deform, especially if we are doing at room temperature. We have already seen. Okay, but here this is not the problem as there is no friction over there. So what can be done? Even the brittle material very easily we are going to deform by this process. Okay, this process is also applicable for ductile metals, and here high reduction ratios are possible. This is not only applicable for the brittle materials, even the ductile materials also we can deform by this process. So this is the major advantage of this one, means both category of material easily we can deform by this process, and whatever the shape or the size we want, easily we are going to get through this extrusion process, especially this hydrostatic extrusion. Okay, so what are the defects which are generally encountered? So this is center burst, sorry, center burst defect. This is piping, sorry, this is piping defect, piping, and this is actually crack. Okay, na? Obviously it is at surface, so this is surface crack. So these are the three defects which is generally encountered during a extrusion process, or which are generally being found in a extrusion process. So what are these? One is, this is center burst, means, and another one is piping. You just see the diagram, and third one is this is. So what is this center burst? We'll see. This is an internal crack, means it is inside the specimen, that develops as a result of tensile stresses along the central axis of the workpiece during extrusion. So this is the central axis. So what will happen? Along this one there will be tensile stress. A large material motion at the outer regions pulls the material along the center of the workpiece. Beyond a critical limit, bursting occurs. What happens? As we are deforming the material, so here everywhere there will be forces. Okay, so because of that, what will happen? This enormous amount of this stress, tensile stress, will develop at the center of the material, that is central axis of the material. And once it will reach its critical point, then what will happen? Burst will happen, cracks will happen at the center, which is known as actually center burst. Okay, so it is only because of the stress that which will be in tensile, sorry, which will in nature it will be tensile, which develops along the center of the specimen or the extruded product. Because of that, this center burst happen. Okay, so what are the conditions because of that it happens? The conditions are, if die angle is high, it will promote this center burst. Extrusion ratio is low, then also it will. And if some impurities are there in the metal, then also this defect will be more prone to happen over there. Okay, this is also known as this cracking, chevron cracking. Okay, this is another name of this one. Second defect is, which is known as piping defect, is formation of a sink hole. It is sink hole at the end of the billet. We can see here it's a sink hole at the end of the billet. This is actually minimized by the use of a dummy block whose diameter is slightly less than that of the billet. We have already seen in direct extrusion process. If we are doing hot working, so what will happen? Scale formation will be there. So, but if we are using a dummy block over there in between the billet and the ram through which we are applying the force, so it defect will be minimized over there. So that has been written also here. And the last defect, that is the surface crack, which will be generally at the surface. The crack will be there on the surface of the extruded product. So this defect actually occurs because of the high temperature that cause cracks to develop at the surface. If the material temperature is very high, we are doing suppose hot extrusion and temperature is very high, so it will appear in the form of cracks on the surface. They also occur at high extrusion speeds, leading to the high strain rate and high generation. Okay, if rate is very high, extrusion speed is very high, then also it's very possibility is very high that surface cracks will be developed. Okay, so next we'll take a wire drawing and a bar drawing. So what is the meaning of this one? wire drawing and bar drawing means you can see here what is happening. Two dies are there, just like all the metal forming processes that we have already seen, especially this bulk deformation processes. What is the basic fundamental what we are following in all the processes? We have to apply the force, whether we are pulling or pushing in a particular die means that particular shape we want, whatever the product we are deforming over there. Similarly, if we have to produce a wire or we have to actually draw a bar, okay, now means we have to reduce the diameter of a bar. Suppose we have a 20 diameter bar and we have to reduce it to 15 so we can do through this metal forming processes also. In wire drawing, generally it is being done in multiple passes. But what is the fundamental in all this, how it occurs? So what actually, just see this, if this is a tube which is having initial diameter of d naught, and what we are doing, we have two die, in between there is a opening, this opening has a particular dimension. So what is happening, instead of, we have already seen in extrusion what were the thing, we were pushing the specimen to pass through the die opening. Here in this, what we will do, instead of pushing the specimen through the die opening, what we will do, we will pull the specimen through the die opening. Just see here what we are doing. This is our workpiece, this is the workpiece that we want to transform its shape, we want to change or deform, we want to deform this material. So what we are doing, we are not pushing, we are not applying the pushing force, we are not pushing it from the back side, rather what we are doing, we are pulling it from the front, means we are applying tensile force. Tensile force, we are not applying compressive force. Compressive force, we are not applying compressive force. What we are doing, we are applying pulling force, and here is the die opening. So once it will pass through this one, definitely its shape is going to change, and whatever the shape of the die opening is, it's going to take. So that whether we are doing wire drawing or we are doing this rod drawing, in all the cases this will be the case. Will pull the specimen through a particular die opening, and that die opening is already defined with dimension, shape, size, everything we know. So what we are doing, we are simply pulling from there. Once it will come out from there, whatever the shape on the size, it is going to take. Just like all the processes, it also may be hot, it may be cold, depending upon whatever the temperature we have chosen to deform the material at. Accordingly it will be different. In this bulk deformation process, a wire, rod or bar are pulled through a die hole, reducing their cross sectional area. Generally in the case of wire, it is not possible in single pass, so multiple passes will be there, and there will be different arrangements of die in the sequence. Suppose wire is passing through this die, then this same wire will pass through this die, then this same wire will pass through this die. So in sequence we are going to reduce the diameter, and finally whatever the diameter of the wire we want, accordingly we'll put at the last, and finally we are going to get this one. Okay, what is the difference between this rod wire drawing and this rod drawing is, it's actually initial stock size. Okay, now the basic difference between the bar drawing and the wire drawing is the stock size that is used for the forming. As I told, wire drawing is not possible in single pass, it will be in multiple, so pool will be there, wire pool will be there, and slowly it will pass through the die, and of course pulling force will be at the outer end, so it will pull it to pass through the die opening multiple, through multiple passes, and finally whatever the dimension or whatever the diameter we want from our specimen, definitely we are going to get through that one. So this is the end of this one, and now as I told different passes, so this is the last one. What is the operating stages of this one? Operating stages means in bar drawing generally done as a single stage, means if we have to reduce this one, just see this one, suppose this diameter is 25 okay now, and we have to bring it to 15 diameter, and if this is a rod, it is possible that we can reduce it by single pass, but this is not the case with the wire drawing. So that's what has been written here. Bar drawing is generally done in single pass. In single pass, it is sufficient to completely reduce it. But this is not the case with the wire, in which the stock is pulled through a die opening. The inlet bars are straight and not in the form of coil, which, yeah, that is obvious. bar will be in the form of bar. Okay, it is forcing, it's going inside the die, and we are reducing the cross sectional area, or we are reducing the diameter over there. But this is not the case with the wire. In contrast, wire is drawn through a coil. It will be in the form of coil, and then it will pass through the die opening, and different die will, with the different diameter, it will be placed in a sequence, and that wire will pass one by one through all the die openings over there, and finally whatever the shape or whatever the diameter we want, that will be there at the final die. And once it will pass through that one, then that particular diameter wire we are going to get from that one, which has been written here. So we'll stop this lecture here, and we'll meet again with some new exciting topic related to this metal forming in next lecture. Okay, thank you.